Hi, thank you for attending. It's great to have you with us. My name's Gordon, and during this period when our training centres are closed due to the UK government's COVID-19 guidance, we'll be providing live training sessions on various topics to help you continue with your progress on your course. We're all centre assessors, and during these difficult times, we're going to be beaming direct into your homes. Please remember to take notes throughout this session. It's really important because as part of the training, we're going to have questions which you'll need to answer online. So stick with it and keep the notes flowing. During these difficult times, there's a very, very high usage of the internet. So sometimes I might cut out a little, but keep with me. You probably still need to hear me. Unfortunately, there's nothing we can do about the worldwide issue of the internet because everybody's on it and most people are working at home. But hopefully it won't cause you too many issues. During the lesson, I'll be playing some videos. If you've got some pop-up blockers or ad blockers on your machine, the video may not play. If the video doesn't play, please refer to our recording of this lesson, which we put online in a few moments after this session's finished. Also, please remember when you log in, if you would just mind putting your first name on your student name, it'd really be helpful. So it's like John FW12345. Okay, today's session is all about series resistors. Now, you may have done a session previously on Ohm's law. This is an extension of Ohm's law. Why is it important? Well, on your third week when you come into a centre, you'll be doing your 602 online exam. 15 out of those 40 questions, which is 37%, are all about series resistors. Okay, so the pass mark is only 50%. So if you get all these right, you're about 3/4 of the way through passing your exam. Okay, so what we've got now is a PowerPoint, a couple of videos. One of them's quite funny on Brainiac. You might find that amusing, but it's a very serious point to it. And then we've got some questions at the end. So let's go straight into the first PowerPoint presentation. So let's open that up slightly so we can see those. So what is resistors in series? Well, if we look at a very simplistic term, if I go back to AV, if we can see this is a circuit, very simple circuit. There's a battery and there's a cable, okay? There's a voltage in this battery, and that voltage pushes current all the way around this cable, this circuit. So any single point on that cable, the current is going to be the same. So if there's 1 ampere, there's going to be 1 ampere, there's going to be 1 ampere. If we put a resistor, and excuse my peg, but it's as good as it gets. So let's assume that's a lamp. The voltage is going to push the current through this lamp and back round to the source. If we then put another lamp on there, so we've got 2 pegs or 2 lamps, okay, the same current is going to be in the, well, it looks like blue, but it's actually green lamp, and it's going to be in the pink lamp. So if you've got 2 amps flowing through this lamp, you're going to get 2 amps flowing through this lamp. That's the basis of a series circuit. Okay, let's go back to the PowerPoint and go through a little bit more detail on that. So Ohm's law, as you probably know, is V equals IR, voltage equals current times resistance. So the total resistance of a circuit is basically just all the circuits or all the resistances added together. So RT equals R1 plus R2 plus R3, etc. Very, very easy. So as you can see, when you've got a series of resistors in a line, all the current will be the same regardless of which resistor you look at. So if in a very simple diagram like this, if we take the one as you look at the screen on the left-hand side, we've got a voltage of 100 volts, and we've got 2 resistances, each of 10 ohms. If we then look on the right-hand side, we've got to work out what that series or what that current is. And if you look at the points A, B, C, each of those will have the same current flowing through it. Where do we get that formula from? Well, if we go back to Ohm's law, V equals IR, and we said all the voltages in the circuit will stay the same. So you've got, let's say, for instance, 100 volts. At each one of those resistances, you'll have another voltage, but they'll all add up to 100. So you might have 10, 10, 10, 10. So 10 different voltages, they'll all add up to 100 volts. If we then substitute Ohm's law into the voltages, voltages equals IR. So if you look at the second or third line down at the screen, IR total equals IR1 plus IR2. If we then cancel the constants, because we've said current's the same, which leaves us the formula for resistance in series, R total equals R1 plus R2. Well, I'm just showing you a little video now, which will go into a little bit more detail, and then we'll come back and we'll do a small PowerPoint with a few examples on it. And then we've got some questions. So keep taking those notes. It's really important taking notes. And actually for the questions at the end, you might need a calculator. So you might just open your phone up and get your calculator on those, because some of them you might be better doing in your head, but it's probably easy to have a calculator.
Okay, in today's video, I am going to go over how to determine the resistance, the current, and the voltages for a simple series circuit. Okay, this is the circuit we're going to use for this video, and you can see it's a series circuit, and you can see it's a series circuit because all of the circuit elements come one after the other. We have the battery, and if we follow the wires along, we come to the first resistor, then the second resistor, and then the third resistor, and then back to the battery. Everything comes in series one after the other. Everything is in one big loop, and that is kind of the definition or how you can recognize a simple series circuit. Okay, what we're going to do in this video is we are going to determine the total voltage gain in the circuit. We are going to determine the total equivalent resistance or the total resistance in the circuit. We are going to determine the total current through the circuit. And then after we've done that, these first three things, I like to call the big three, because once we have that, then we can get the current through each resistor, and then we can get the voltage drop across each resistor. Okay, so let's get started, and we are going to start with the total voltage. Now, this one's relatively simple, but I think it's good to write everything down and have all this down on a piece of paper so you think about it. You have these values down so you can use them when you do your calculations. The total voltage gain in the circuit is just the voltage of all the batteries in the circuit, or everything that's providing energy to the circuit. Now, in this case, it's very simple. There's only one battery. It's a 12-volt battery. So the total voltage gain for this circuit is 12 volts. And I just put down VT, voltage total, is 12 volts. Okay? Nice and easy, very straightforward. Okay, now the equivalent resistance. Now, this is a series circuit. So we need to be thinking about our rules and our equations that we use for series circuits. And for series circuits, it's nice and easy. The total resistance, the equivalent resistance, okay, I use those back and forth. Equivalent, the total resistance is R1, the resistance of resistor number 2, and the resistance of number 3 just added together. So it's 5 ohms plus 9 ohms plus 7 ohms. And that simply adds up to 21 ohms. So the total resistance of this circuit is 21 ohms. Now we can get the current. Now, in order to use the current, we're going to have to use Ohm's law. V equals I times R. And I'm sure your teacher has told you, or you have learned the way to remember this. Twinkle, twinkle, little star. V equals I times R. See? Very simple. You'll never forget that equation. Now, we want to find the total current. So this is the symbol, the I is the symbol for current, voltage, and resistance. We need to isolate this by itself, so we're going to divide each side by R, and therefore we get that the total current, I total, is equal to V total divided by R total. Now, I specifically put down here I total because when we calculate the total current, we have to use the total voltage and the total resistance. You can see now we really have 4 different resistances, R1, R2, R3, and the total. And you need to remember that when you calculate the total current, you need to use the total resistance. Total, total, total. Okay, the total voltage we figured out was 12 volts pretty easily. We added up the resistances. We got 21 for the total resistance. And therefore, the current through that circuit, the total current through that circuit is 0.57 amps. Okay, and
Okay, we go back up to AV. There we go. Right, you saw in the video the 3 ways we need to do, as he called it, the trilogy, working out the total voltage, which is literally the voltage coming from the source, the battery or the power supply. The total resistance is literally just adding all the resistance together. So resistance 1 plus resistance 2 plus resistance 3. And then to find the current, using Ohm's law, you're dividing the voltage divided by the resistance total. So let's say in a standard house, you've got 230 volts. You've got 10 resistances of 2 ohms each. So 10 times 20, so it'll be 230 divided by 20, which will give you the current in the house. And as we said before, in a series circuit, the current is the same regardless of what resistor you're looking at. Okay, now I've got a little PowerPoint now with some questions on. We're going to go on examples, should I say, we're going to go through. Okay, let's have a look. If we look at this particular scenario, we've got a 30 volt power source. We've got a 20 ohm resistor. So the scenario here would be 30 divided by 20, which gives us the 1.5 amps flowing through the circuit. And you see the 2 points on the left and right of the circuit is exactly the same. It's 1.5 amps. Just skip along to the next one. In this one, it's a little bit more complicated, but in the same scenario, we've got 2 resistances now of 20 ohms each, and we've got a power source of 30. So it would be 30 divided by 40, which gives us the 0.75 on the current. We're not going to go into voltage drops on this particular session. That's going to come on a little bit later when we do parallel circuits. Okay. So an example, a final example we're going to do here. We've got 100 volt as a power source, and we've got now 2 separate size resistors. We've got a 70 ohm resistor and we got a 30 ohm resistor. So again, using the formula on the top right hand side where it says what's the total resistance, we add the 2 together, which gives us 100. We then divide, if you look at the left hand side, we've got classic Ohm's law, I equals V over RT. So it'd be 100 divided by 100, which gives us 1. And as you can see, the current on the left and the right hand side of the circuit, and indeed the middle at the top, you've got 1 amp. So just reiterating, 1 amp is the total current, and on a series circuit, regardless of which point you check that, it's still going to be 1 amp. Okay, and so hopefully you've made some notes on this. I'm just going to show you a final little video, which is quite funny, but it actually goes into Ohm's law. It's showing you all about resistances. Okay, the more resistances you put into a circuit, the less current you're going to have. And then we've got some questions at the end, so keep making these notes. Here we go.
Ever held onto an electric fence? It hurts. Farmers use electric fences to keep cattle in and foxes out. If an animal touches the fence, it gets a shock and it runs away. Today, by holding on to this fence designed to shock horses, the brainiacs are going to learn all about electricity. This brainiac is going to touch the fence and get an electric shock. This happens because when he touches the fence, he completes the circuit between the live wire and the ground. The charge goes from the fence itself into the brainiac, through the brainiac's body and down into the ground. Then it goes along the ground into the earth stakes, along the earth wires and back into the unit to complete the circuit. Down! And it hurts. Okay, he's getting pretty fed up with that. So what happens if he stands on these polystyrene tiles? Brainiac, touch the fence. The electricity won't pass through the Brainiac's body because it can't go through the polystyrene tiles to the ground to complete the circuit because they're a good insulator, so no shock. Off the tiles, shock. On the tiles, no shock. Off the tiles, shock. Every time this light flashes, there's a charge in the fence. Now, if the Brainiac's feet aren't touching the ground when it flashes, he shouldn't get shocked. So if he can jump at the right moment, he'll be fine. Brainiac, are you ready? Excellent. On. Look, grab the fence, do it when I say on, be in the air. Here you go. On. Do you have no sense of rhythm? It's not difficult. You need to work on your timing. Or maybe we need to work on that theory a bit. What's better than shocking a Brainiac? Shocking a whole load of them. In you go. All our Brainiacs have bare feet and they're holding hands, as you do. Now, what will happen when the Brainiac at that end grabs the fence? It might just go straight through him to the ground. It might make it all the way to here. Will this Brainiac even feel it? Who knows? Let's find out. Brainiac, on the count of 3, grab the fence. 1, 2, 3, go. Hang on, so you haven't even moved. How far did it get? It got that far.
It got to this now.
Rate that out of 5. 1 to 5, how much did it hurt? 2. 1 to 5, how much did that hurt?
4.
4, right. Change order and let's do it again. Hold hands. On 1, 3, 2, 1, go. You didn't feel it at that end? So it earthed by there. His eyes are still spinning. It seems that the current has never got past this Brainiac here. So maybe he has unique insulating properties. Who knows? There's only one way to find out. Stick him on the end. On you go. You go and grab the fence, and on my count. Ready? 3, 2, 1, go. Whoa, now that went further. Where did that end up? Did you feel that? That went as far as that Brainiac there. It's killed that Brainiac. That's quite impressive.
Okay, it was a funny video, but there were some very serious points in there. We're talking about current, we're talking about resistance, we're talking about voltages. Okay, when we look at parallel circuits, that will become a little bit more applicable to when we're talking about those 3 particular elements of voltage, resistance, and current. Okay, hope you've made lots of notes because we've got 8 questions now. When you answer the questions, it's a series of A, B, C, or D. You'll get immediate feedback how well you've done, and then we'll go over the answers and you'll see the correct ones come up in green. Okay? Right, let's pull those up. Okay, here we go. First question. When the supply current in the circuit, or what is the supply current in the circuit, if there are 2 resistors in series of 20 ohms and 30 ohms, if there's a supply voltage of 200 volts. So we'll go through this one together. Circuit, series, what do? We add up the 2 resistances. So we got a 20 and we got 30. Add them together, that gives us 50. We then use in Ohm's law, I equals V over R. So we divide the voltage, which is 200, by the resistance, which is 50. So that'll be 200 divided by 50. So the correct answer would be 4 amps, which you probably knew that anyway. No more tips. What is the total voltage if the supply current is 4 amps and there are 2 resistors in series of 10 and 20 ohms? It's all Ohm's law. You just transpose in V equals IR. Question number 3. When the current passing through a conductor is increased, the conductor's temperature will... So what's going to happen to the cable? and the current goes through it. A 12-volt battery is connected across a set of resistors in series. The values of those are 60, 30, 100, and 45 ohms. What would the current flowing through the circuit be? Question number 5. 4 lights are in series. Each of them are 12 ohms. They are attached to a 110 volt supply. What's the total current being used? Number 6. 2 electrical fires are connected in series. Don't forget, any load is a resistor. So ignore the words, just look at the numbers. 2 electrical fires are connected in series. They both have a voltage drop of 24 volts across them. What is the total voltage of the circuit? Penultimate question. 3 lights in series have a current of 10 amps passing through them. What is the total circuit total current circuit? And finally, question number 8. What is the resistance of the second lamp in a circuit if the voltage is 230 volts, the circuit current is 10 amps, and the resistance of the first light is 13 ohms? That's a tricky two-parter. I'm sure you'll work it out. Okay, well done. Let's see how well you've done. So you should have got your answers back by now. Okay. Now I'll just scroll down the individual answers. Obviously, number 1, we did together. Number 2 is A, 120 volts. Number 3, whenever current passes through a conductor, it gets hot. Okay, so the temperature will increase. Number 4 would be D, 51 milliamps. Number 5, C, 2.29 amps. Number 6 is A. Number 7, B. And finally, number 8 is B, 10 ohms. Okay? Let's go back up. Okay, that's concluded this presentation on series resistors. The key thing is this: it's all about Ohm's law. It's no different doing Ohm's law, no different when we do one on parallel resistances, no different when we do it on power. But it's one of the most important sessions you'll do. Going back to the figure, it's 37% or 50% you need when you do your 602 exam in week 3. So it's really important to get your head around that. So maybe relook at this video. So thanks for attending. It was really great to have you with us. There's more sessions coming up, so please keep an eye on Student World and then book yourself in for sessions which are appropriate for you. So please stay indoors, stay well, stay safe, and see you on the next one.